In this video, we're going to look at changing a data preparation process that passes data to one of CDS's match processors for duplicate identification purposes. So we're not going to look at changing data interfaces or web services at all this time. We're just looking at changing a process. Now, the particular example we're going to work with concerns an American zip code. So usually, if it's available, CDS will use as much of the zip code as it can. It will use both the primary part of the zip code and the secondary part. So if you know American zip code, you'll know that the primary zip code usually has 5 characters in it and the secondary zip code has 4. And usually CDS will use both of those. But what we want to do in this example is to adapt the CDS process, or one of the CDS processes, so that only the primary zip code, only the first 5 digits, are sent to the match processor for duplicate identification purposes. So what we want to do is to make a change to one of the data preparation processes to alter some of the data that's going into a match processor. And we're going to take as our example the real-time entity match service. So we use that as our example. And you can see that is running in the server console here. We're on the current tasks view and you can see it's running now. So let's go to the web service tester and let's just investigate a little bit about how it works. So we haven't made any changes yet. So I've called the entity match service here and I've actually input data for a couple of records that we can try matching together. So let's have a look at them. Here's the first record. And I'll just walk you through the data I've put in. Name, entity name, that is Oracle Corporation. And then further down, address 1, 2320 E. Valencia Drive. City Fullerton, admin area CA for California, country USA. But note the postal code, the zip code in other words. So in that field, we've got 92831-4904. That is the primary and the secondary elements of the zip code. The first 5 characters being the primary element and the last 4 characters being the secondary element of the zip code. So in record 1, we have both the primary and the secondary zip code. Now record 2, if I move down to that now, it's actually got exactly the same information in it, in every field that's populated. So again, name Oracle Corporation, address 2320 E. Valencia Drive, Fullerton for the city, CA for the admin area, USA for the country, and exactly the same zip in the postal code field, 92831-4904. So in both the records we're going to try and match together, we've got exactly the same zip code and both the primary and the secondary elements of the zip code are there. Right, let's go to the top and let's hit send. And we should see the results on the right here when we hit send. We'll hit send now. And let's see what matching does. Well, we find a very, very strong match. Match score 100. Now, in CDS, match scores are on a scale between 0 and 100. So this is as strong as a match as you can get in CDS. And look at the rule. It's matched on full name exact and address. And if you went to have a look at that rule in the match processor, you'd see the address needs to be exactly the same, which it is, of course, including the 2 zip codes. All right, let's make a change to one of the records. In the first record, and the first record only here, let's remove the secondary element of the zip code, 4904, that's gone. Now we've just got the first 5 characters, the primary zip code, 92831. In the second record, we'll leave that exactly as it is. So the secondary record will retain both the primary and secondary elements of the zip code. So we now have just the primary zip code in the first record and the primary and secondary elements of the zip code in the second record. Okay, let's go back to the top. Let's hit send again and let's see what change that makes to the matched results. So you can see now we've still matched, but we've got a slightly weaker match score 93. So the strength of the match has gone down a little bit. And the match rule we're matching against is also different, as we'd expect. This time it's full name exact, premise, no sub-premise, postal code starts with. Because not all of the postal code is the same. The start is the same, the first 5 characters are, but one of the records has a secondary zip code as well as the primary zip code. The other one doesn't. So the match is different because of taking out that secondary zip code in one of the records. Now, you could make an argument that, in fact, you don't want match to work that way. If a record has the secondary zip code missing, but the primary zip code and the other details are the same, it should still be the strongest match we can get. You could make that argument. And so what we're going to do on that basis is we're going to look at how we could change the data going into match so that the secondary element of the zip code, if it's present, is discarded as far as matching is concerned. And matching only takes the primary element of the zip code into account. So let's look at how we can do this. So what we want to do is to change the way that postal codes, or zip codes if you like, are prepared before they're sent to the real-time entity match processor. Now, how should we go about doing that? Well, let's start by looking at the real-time entity match job. I often find that jobs are the best starting points when we want to investigate how CDS works. So let's find that. Here we are in the jobs node in the project browser within Director. And there's the real-time entity match job. Let's just double click it to open it on the canvas. There we go. And here we can see all of the processes within the job now. Now a process is denoted by 3 yellow balls joined together. So if I just move down, you can see quite near the bottom of the job, there's the match entity process where the matching actually happens. But if I go further up, you can see further up, quite near the beginning of the process chain is standardized address. So that's where the addresses are prepared for real-time entity matching in this process. So let's open that process and have a look at it. We'll right click and we'll choose open, and that process will open on the canvas. And you can see the second processor in that standardized address process is called standardized postal code. So this is where the postal codes are standardized, and if we right click that, we can open it because it's a composite processor, and we can see all the processes that make it up, and here they are. So we could add some more logic here. We could customize this composite processor in order to strip out the secondary element of the postal code or the zip code if it were there. We could do that. That would be an option. Or we could add another processor in to the standardized address process, perhaps directly after the standardized postal code processor, again to strip out the secondary element of the zip code. That might be a bit more visible and easier to spot in terms of anyone else looking at what we've done. But actually, we should be rather cautious before we start making changes to this process. And the reason is that we should just give some thought to where else in CDS may this process be used, because it might not just be used in the real-time entity match job. So how will we find out? Well, let's find the process. It's called standardized address. Let's find it in the process node here in the project browser. And there it is, standardized address. And to find out where else in CDS it's used, we can create a dependency filter. So let's right click on the standardized address process, and we've got a dependency filter option, and the option we want is items using selected item. So what other bits of CDS use this standardized address process? That's what we're looking at here. Let's click there. And you can see the dependency filter is now on. And further, you can see that all of these jobs, and there's quite a lot of them, pass that dependency filter. So in other words, all of these jobs that we can see here use that standardized address process, not just real-time entity matching, but all of these. Let's just have a look at one example. Let's go to this batch address cluster job at the top here, and we'll open it on the canvas, and it's got quite a few phases. And if we just go to the bottom phase called address cluster, here you can see the standardized address process is used in that job. So it'll actually be used in all of these jobs. Now, therefore, if we make a change to that process, it will affect the way that all of these jobs work. Now, does that matter? Well, in order to answer that question, you'd have to do a lot of investigation. Maybe you want to change the way that your postal codes are prepared throughout the whole of CDS, but that could have unforeseen consequences perhaps. So maybe a safer option would be, instead of just changing this standardized address process, why don't we instead take a copy of it and then change the copy? We can call it something different, call it standardized address customized or something like that. And then just within that batch entity match job, let's replace the generic standardized address process with our customized copy. And then we can be fairly sure that that will only affect that one job and not any of the others. So we'll go forward in that manner. So let's begin. There is the standardized address process there. Let's just right click. Let's copy it. We can take off our dependency filter now. Just click on the process node and then paste in the copy, and it will say you can't have two of the same name. Well, that's fine. We'll call this tailored. Whoops, if I can spell it. Tailored standardized address. Okay. So what we've now got, if we just look in the project browser near the bottom of the process, I guess there, that's our copy of the standardized address process with a different name. And we can now make a change to that and then insert that into the real-time entity match job. So next, we'll look at what sort of change we need to make. So how do we go about changing this tailored version of the standardized address process? Well, first of all, we should do some investigation. And you can probably guess that the area, as we've mentioned, where the postal codes get standardized is in this composite processor called standardized postal codes. So really we should open that and we should try and get a sense for what it's doing and have a good look through its logic. I won't do that just now, just for sake of brevity, okay? What I'm actually going to do is just run some data through this process to see what it does. And we'll look particularly at the postal code. Now, if I run the process as it is, it'll error out. Why? Well, the reader is reading from a data interface called combined data preparation. The writer is writing to the same data interface. And the data interfaces, remember, are just attribute templates. They need to be mapped to real sources or targets of data. And if I have a look at the run preferences of this process and select the reader, there is no mapping, and the same for the writer, no mapping is selected. So what we're going to do is just create a little web service with one input and one output to look at the postal code only, and then a mapping for that web service to this data interface, and then we'll run it again. So let's just go down to the web services node here, and we'll create a new web service. And as I said, we'll just put in a single attribute for input, which we'll call postal code. There we go. And a single attribute for output too, and we'll call that one standardized postal code. There we are. And we'll call this web service just tester. So it's only going to look at the postal code. We're not interested in the rest of the address. Now let's go up to the data interfaces node and find our combined data preparation data interface that our process uses. Let's right click it and let's choose mappings, and we'll just create a new mapping against RealTime for our little tester web service. So this one's for inputs, tester in. And we'll map the postal code from our tester web service to the postal code attribute in our data interface. There we go. And we'll call this tester in. So that's our input mapping. And we need one for output as well so we can see the results. So again, choose real time. Let's again choose tester, this time data out. And this time we want to map not the postal code, not this field, but if we go further down, you'll notice there is a field called postal code standardized, and that holds the output of this process. So we want to map that. And we'll call this mapping tester out. So we've got two new mappings for the data interface. Let's go into the run preferences of the process now and hit the reader, and let's choose our tester in mapping, hit the writer, and let's select our tester out mapping. So now it's mapped. We can now run the process and it should run happily. Having done that, we can go to the Launchpad and let's fire up the web service tester. And what we want to see, let's just select the CDS project first of all, and our little tester web service, and we'll get the service. Now what we want to get an idea for is what happens to postal codes as they go through this standardized process before we make any changes. So what we'll do is we'll put in a sort of a test, 1, 2, 3, 4, 5 digits, like the first 5 digits, the primary element of a zip code, dash 9876, 4 digits, the last 4 digits of the zip code, the secondary element of the zip code. So if we just send that, and it may take a little while to come back with a result because I'm working in a rather underpowered virtual machine, and you can see whilst this symbol here is going around, it's still thinking. But let's see, it's come back with a result now, and what I want you to notice is that what this has done is stripped out the dash. So the process, and we're going to assume it's that standardized postal code processor. Take my word for it, it is. You could test that if you want to, but let's just say it is. The process already strips out the dash, so we don't have to worry about this dash. Whatever we do doesn't have to take that into account. We just want to take off the last 4 digits here and end up with the first 5 digits, which is the primary element of the zip code. Okay, so let's bear that in mind. Now let's go back to Director and let's just stop this web service. We'll just stop it as quickly as possible because we don't want to look at the results. And what we're going to do then is we're going to add another processor directly after the standardized postal code processor here. And if we do that there, it will just be very visual. Anyone that comes along to look at it will get a good sense very quickly of what we've done, I think. We'll keep it simple. Now let's just make some room. So we'll shift all of these processors up a little bit over here, look. There we go. Won't worry too much about being ultra tidy. Just now, we could tidy this up later. Shift them all across like that. Okay, now we've got some room. And we'll delete this link, and we're going to put our processor in between these two. Now, what processor could be used to take out the last 4 digits of that zip code? Well, there's a few possibilities. One would be trim characters here. Another one would be regex replace. But the one that we're going to use, just to keep things really easy, is going to be called pattern transform. So let's bring that onto the canvas. And this will just transform the postal code based upon patterns. Okay, let's hook it up. Now, actually, before I do, we'll look at the standardized postal code processor and note it takes in the postal code, it adds a new field called postal code.standardized. So that's the field that we'll want to bring in. That should be the input for our pattern transform processor. So let's find that added field. There it is at the bottom there. It's the one we want to transform. Let's go to options. Now, this pattern transform processor expects some reference data, and actually I've already created it. So I've cheated a little bit. And it's called secondary zip strip. Here it is. So let's hook that up. And we'll just take a quick look at that reference data actually. Let's go to the reference data node here. And let's just find it. So it's a little bit further down, I think. There it is, secondary zip strip. So there's a pattern and there's a mapped pattern. This is the lookup column. This is the return column. It's looking for 9 numbers. The way that we represent numbers in a pattern is with ends. So there are 9 ends there if you count them out. It's looking for a pattern with 9 numbers. Primary zip code 5 numbers, secondary zip code 4 numbers. The dash gets taken out, so it's looking for those 9 numbers. And if it finds them, it's going to return just the first 5 numbers. So in the mapped pattern, we've got 5 ends. Okay, so it should strip out the last 4 numbers. If it finds anything other than 9 numbers, it won't do anything. Okay, so if, for example, there was a UK postcode which would not consist of 9 numbers, it would be start with 2 letters, for example, then it would just ignore it. So it's going to expect an American style zip, but without the dash. Let's take the output from that pattern transform processor. Let's pass it on to the next processor in the chain. So we're just inserting it really. Okay, last thing we want to do is let's just take a look at the writer here, data preparation interface. And that's writing out to the data interface, which we know is now mapped to our little tester web service. And what that web service is getting, if you remember, is the postal code standardized field here. So what's actually being written to that postal code standardized field? Let's find out. And there we go. What's being written is postal code dot standardized. Now that was the output from the postal code standardized composite processor. Remember? And if I just go down and have a quick look in the available attributes on the left, and we look at the added ones, there is postal code dot standardized, and it has two versions. Postal code dot standardized, which is the one that's being output, and postal code dot standardized dot pattern transform, which is the version of that attribute after we've done our pattern transformation. Now obviously we want to output the version after we've transformed the pattern and we've stripped out the last 4 digits. So actually what we're going to do is get rid of that postal code dot standardized attribute for writing. Let's do that. So now the postal code standardized field in the data interface is not mapped to. Let's put in postal code dot standardized dot pattern transform. There we are, and let's map it up to our postal code standardized field in the data interface. So that's now nicely mapped. Okay, we'll just save that, and having made those changes, we'll run it again. There we go, so that's now running. Let's go back to our web service tester. In fact, I think we'll just come out of the web service tester and back into it, because it may confuse it, because I'm not sure actually. I've made that change to the data interface, but anyway, let's not worry about that too much. Whoops, gone to the wrong place. Let's try again. Web service tester. There we go. Better. Right, let's call our EDQ-CDS project again, and let's select our little tester web service, and we'll get it again. There we go. And let's see what happens now. So I'm going to try a similar test. 1, 2, 3, 4, 5. So 5 numeric characters, like the start, the primary element of the zip code, dash 9876. The last 4 characters numeric, like the secondary element of the zip code. Let's hit send. Again, first time we do this, it may take a while to actually come back with the result, but it's done it now, and you can see it stripped out the last 4 characters. So it's done what we hoped it would do. So if it finds an American style zip code with primary and secondary elements, it just returns the primary element. Okay. Now, just to make the point, if I put in a British postal code like that, obviously a different format, we haven't got the pattern that we've set in our reference data as the lookup, and you can see it does nothing to it. Okay, just leaves it alone. So it's only if it finds an American style zip code that it's going to actually strip it out. I'm not saying this is the only way to do this, or even necessarily the best way. There may well be more foolproof ways, but I'm just trying to show you how we would go about adapting a CDS service, and you can figure out the best way to do it yourself. Okay. All right. So having done that, let's stop that process running. Now let's just remind ourselves of what we've done. What we've actually done so far is taking a copy of the standardized address process and called it tailored standardized address and changed it and put in another processor. What we do next is we go into the job, the entity real-time entity match job, and we swap out the old copy of the process for our new tailored copy, and then we'll test that as well. So we'll do that bit next. Okay, so let's look at how we're going to change the job now, real-time entity match. And in fact, what I'm suggesting is we don't change this job at all. We in fact take a copy of it, and we create a paste it into the jobs, and we create a copy which we'll call tailored real-time entity match. My thinking here really is that if we come to, let's say, upgrade or something like that, it might be a lot easier if we can easily see what changes we've made. So rather than just having a change within a job with the same name, let's actually create a job with a different name. So there's our tailored real-time entity match job. And within that tailored version of the job, let's now delete the standardized address process from it. And let's replace it over here in the tool palette. Look, we can see the list of processes. Let's replace it with our tailored standardized address process. There we go. We'll just pull that over a bit and we'll hook it up. So there we are. We're just simply inserting that in the same place as the non-tailored version of the process was, but within our tailored version of the job. So let's close that. Now, to run that job, we run it from another process actually called RealTime Start All. And that does some preparation of various things that matching needs before it then, in this last phase, if we have a quick look at that, starts the various real-time matching services, including real-time entity match here. So again, what I'm going to do is rather than just change that, I could just change it, but actually I'll do the same again. I'm going to copy it and I'm going to paste it in and change its name. So we're going to have our own version of it and we'll call it tailored. Tailored real-time start all. Okay, so let's open up our tailored real-time start all job. There we go. Let's go to the last phase and we'll hit configure. So these are just triggers that start various jobs, and we want to take out this real-time entity match trigger here, which is after real-time entity cluster, and we want to put in a trigger to start the real-time, the tailored version of that real-time entity match job. There we go. And we just want to make sure it's in the right place. So it needs to move up so that it's after let's find that real-time entity cluster. So that's it, it's in the right place. All right, so there's our real-time entity match tailored version of the job there, started by that trigger within this tailored version of real-time start all. Let's save that and we'll close it down. And what we'll do now is go into the server console. Let's find that tailored real-time start all and let's run it. Okay, so that will start to run now. It'll take a little while to do the preparation steps before it actually runs real-time entity match. So I'll come back to you in a minute when it's all running, and then we'll test it using the web service tester. Okay, so real-time start all has started all of the real-time services now, including real-time entity match. There we go, just there. So we can go off to the web service tester and we can see if our changes have worked. So let's go to the web service tester, and remember what we were trying to achieve. We were trying to make sure that whether or not the secondary zip code was present didn't matter. As long as the primary zip code is there, the first 5 digits, what's in the secondary part, whether there's nothing there or something there, or whether there's differences between the two records, it shouldn't make any difference to the result of matching. So what I've done is I've entered exactly the same data into the entity match service here in the web service tester as we did for our initial test at the beginning. So in record 1, here at the top, I've got Oracle Corporation as the entity name and address 12320 E. Drive. And city Fullerton, admin area CA for California, country USA. And in record 1, we've got the primary and the secondary zip code, look, 92831-4904. In record 2, exactly the same details. candidate ID is obviously different, but otherwise Oracle Corporation as the name, 2320 Valencia Drive as the address one, Fullerton, CA, USA. The only difference, apart from the candidate number, is the postal code, the zip code, which only has the primary zip code in it, 92831. Now, when we tested this right at the beginning, we found that the match score was 93, wasn't it? And it was a weaker match score than if we had the primary and secondary parts of the zip code also matching. Let's send it now, and let's wait for it to come back. It's come back already, and if you look now, match score 100, and we're matching on full name exact and address, and the address is exactly the same, it thinks. Okay, so what we've managed to do then by making that change is effectively to get the entity match service to ignore the real-time version of it anyway, to ignore the secondary part of the zip code. Whether or not I have the secondary part of the zip code in my records doesn't matter. As long as the primary part of the zip code is the same, the secondary zip code doesn't make any difference. If I just put the secondary part in the second record as well, just to show you it won't make any difference, I'll put that in, 4904. So the records are now exactly the same, apart from the candidate number, which always must be different anyway. That's just an internal thing, and you can see we've got the same result. So it's now ignoring the secondary element of the zip code.